Okay, so like I just mentioned, the topic for today that we are looking at is our kind of final topic, and it is going to be looking at probability. So the key kind of areas we're going to look at, we're going to have a very quick introduction to what probability is, and then we're going to move on to our kind of non-numerical probability. It's really just the concept of probability, looking at likely, unlikely, even, certain, and impossible outcomes. So this can pop up on level 1. It doesn't seem to be as common anymore. Originally, it was. It can still pop up, but it's not quite as common. But it gives us a very nice kind of introduction into how to think about this. We're then going to look at the main part of our kind of presentation, and that is simple probability problems. They're all based on the same idea. The majority of these are reading information from a table and then stating the likelihood of something occurring. So we're going to look at these, and we're going to spend quite a bit of time on these, looking through a couple of different kind of exam style questions, really just underpinning that skill there. A lot of people think of probability and they think, oh God, it's going to be horrible. At functional skills level, it's actually quite nice and straightforward, really. So this is relevant for all for level 1 and for level 2. We're then going to have a look at the idea of, is something fair? Again, very, very short topic, literally one question for you, but just to make you aware of the type of thing that you might be asked. Again, relevant for level 1 and level 2. And then finally, we're going to look at our probability trees and dual probability. So dual probability is the idea of having kind of two outcomes. You know, there's a 70% chance of this happening, but then there's a 30% chance of this. It's where people tend to find it gets a little bit confusing. There's a very straightforward way of solving the problems, but I know for a lot of people, having that understanding does actually really, really help. I will give a couple of explanations here, and I'll do my absolute best to explain exactly what's happening. And again, I'll try and explain it in 3 different ways, which hopefully will help. The main thing, though, is just remembering it's only for level 2 learners, and it is the least common type of probability question to pop up. And it's always a 3-mark question. It's very easy to get 2 of them. That's the main thing. There's then some review materials and obviously assessments that I will show you where these assessments are on the Google Classroom, or obviously give reference to it for the recording. And then at the end of this presentation, there are multiple kind of random kind of exam style questions. So what we can then do is, if we choose to, we can then go through that. But if you are kind of having a look at this recording, it might be worth having a look through the PowerPoint on its own, and then kind of completing the questions as we go, or as you go through, because they've all got the answers completed with them as well. Bit of an overall recap to, you know, everything that we've looked at. Okay, so what is probability then? Probability in itself is the likelihood of an outcome occurring. So it's how likely something is to happen. We can measure this as a decimal, a fraction, or a percentage, which, if we think about it, makes sense. You know, when we're talking about percentages, fractions, or decimals, it's looking at a part of a whole. That's what an outcome is. If there are 2 different outcomes, there's 2 potential things that could happen in the whole scheme of things. In regards to language, mathematically, we look at probabilities in decimal form quite a lot. However, in our language, in kind of common use language, we would tend to hear percentages or fractions a lot more frequently. Fractions are used but not really thought about very often. You know, there's 17 out of 30 people enjoyed dinner. That is a probability. There is 17 out of the 30 people that enjoyed the dinner. So it is just a fraction on its own, essentially. Percentage, again, tends to be a bit more straightforward. And I have seen some questions on, you know, a level 2 paper where it has just said, you know, there's a 70% chance of it raining. What is the chance it will not rain? So hearing it as a percentage can be a very, very useful one for us as well. Being able to switch and convert between these makes our lives a lot easier as well. So seeing something as a decimal, but then viewing it in our heads as a percentage can be really, really useful. So conversion tools can be a big kind of help here. So in functional skills, we might be asked to give kind of probabilities in a couple of the following ways. So it could just be a straightforward question, like I just said there. You know, if there's a 60% chance that it's going to snow, what are the chances it will not snow? it can be that nice and straightforward. It tends to be that these questions are linked in with tables, either filling in a table or reading probability from a table. They really like to involve this with the data and statistics side of things. It can also be in a graph as well, and this is kind of similar to how we were saying, yeah, the majority of bar graphs tend to be for level 1 learners, but we could get a bar graph question for level 2 learners, and it could be something where, you know, we have to work out the overall total, and then again, you could see where a fraction could link in here. Well, there's 80 out of the 110 people here would like to have a blue car. That is a probability. It's saying, you know, if you were to pick out of all these 110 people, 80 of them would like to do this. You could work out a percentage from that, etc. So our very kind of nice starting point that we have is just this idea of the likeliness or the likelihood of certain things occurring. It's the most straightforward. It really does set us up nicely for the topic. And, you know, if you're a level 1 learner and you get this type of question, yes, that's brilliant. It is simply a case of stating in kind of a word form, what is the likelihood of something happening? They can use a number line for this. I've seen that kind of pop up as well, where they have maybe 1 here and 0 here. And they ask you to kind of put an X on the line where a likelihood of an event would be. Now, the thing that you need to bear in mind with probability, although there may be 2 outcomes, we're talking about which is more likely to happen. That's where some people can get a little bit confused. They can look at it and go, well, there's 2 outcomes, so it's 50-50. But if we think about it in terms of, I know, the likelihood that I'm going to finish teaching this session, that's very high. You know, I'm more than certainly going to, I hope. You know, I hope nothing happens to me now. I think I've jinxed myself. But that is very likely. Although the 2 options are there, I'm either going to teach the full session or not teach the full session. This one is considerably more likely to happen. So it's not a 50-50 chance. That's the whole thing with probability. It's how likely something is to happen. So if something is impossible, it has a 0 chance. 0%, 0 is a fraction, 0 is a decimal. We're just going to write these in all the different forms. If there's an even chance, again, the prime example being flipping a coin, for instance, then there is a 50-50 chance. There's a 50%, a half, or 0.5. They all mean a half, and again, this is where the conversion skill and topic really does come in and help us. If something is certain, then it is going to be 1 as a decimal, 1 as a fraction, or 100% as a percentage. Again, fractions and decimals are out of 1. % is on a scale of 100. Certainty is something that does come in quite a lot. And again, we have to think about, and we will think about this a bit more later, if there are 2 outcomes that are going to happen, then really there is a certainty that one of them will occur. So like I said, I'm either going to teach the session or I'm not going to. There's no middle ground. There's no way that I kind of teach it but don't. Well, you could just say I'm really bad at teaching, but I'm not. I'm awesome. So the middle grounds that we've got then is this unlikely and likely. You could see it as maybe 25% and 75%, but it doesn't fall into that specific bracket. Essentially, if something's more likely to happen, it's more than even, more than 50%, but less than 100. That's where it falls. So anywhere between 51% and 99%, anywhere there, that would be a more likely outcome for us. So you can put numerical data to it. A lot of the time you can just, you might get a question as nice and straightforward as this, and then just verbally have to tick the box that you agree with. You know, how likely is it that it will snow tomorrow? Obviously, it depends on where you live. There are some subjectivities to it. We live in England. We get a good slush sometimes, but that's about it. The chance of it snowing tomorrow is unlikely. Okay, it's not impossible. It can happen, but it's definitely not an even chance. It's not half the time it snows, half the time it doesn't. That's the difference here. So it's an unlikely thing to happen. The chance of getting a heads when I flip a coin. You know, if it is a fair coin and a non-biased coin, and we'll look at this a little bit later, then the chance here is going to be even. It's 50-50. It's one of the main things that we tend to see in regards to an even chance there. The probability that this is a dog. So hopefully we are in agreement. This is a cat. Therefore, it is impossible that it's a dog. It might be a very doggish cat. It might chew bones and do other dog-like things, but it is a cat. Now, I couldn't think of a different outcome that was impossible. That's not the best reason, but I'm hoping that you get the point there. Okay, in regards to an exam style question, what this might look like, and this is kind of looking at a level 1 exam paper. It was from a different exam board, but again, very, very similar. We could get something like this. So we have Geeta has a spinner. People love spinners, apparently. I don't know why, but they're always kind of present here. So Geeta has a spinner, and it's got these 4 numbers on it. What is her chance of spinning the numbers in the boxes below? Match each of the boxes with the correct word. One has been done for you. So the one that's been done there, an odd number occurring, there is an even chance of that. Well, if we look, that makes sense. In this case, it's split into 4, and we can kind of visually see there that all 4 of these are the same size. We've got 3, 4, 5, and 6. 2 odds, 2 evens. So it is a 50-50 chance there of it occurring. So if you think about it as a fraction, 2 in 4, simplified, that's going to be a half in regards to how likely it is to occur. I'm liking that, Emmanuel, 1 step ahead of me, as always. So the next question then is, okay, well, what is the likelihood that a 2 is going to appear? I should have used this for my example in the previous one, really. But the likelihood of a 2 popping up, it's impossible. It's never going to happen. I can spin that spinner all day. It is never going to land on a 2 because there's not a 2 on it. So that is an impossible outcome. Finally, getting a number that is less than 10. Well, I've got 3, 4, 5, and 6. They are all less than 10. So that is a certainty. We are definitely going to get a score there. Yeah, you're 100% when you spin that, you are going to get one of those numbers. Okay, so that's our very nice kind of starting topic. What we tend to find, though, is that we need to be very happy with putting some numerical values to this data as well. We've looked at the idea of, 100% or 0 or 50, but there's all those other kind of scales in between as well. So sometimes we might be asked to fill in probability on a table, and they like to do this with decimals. It's the same when we see our probability trees later. Mathematically speaking, looking at a probability as a decimal is the easiest and most straightforward way of writing it down. When we look at it as a fraction, that's an unfinished sum. When we look at it as a percentage, we're making it 100 times bigger. Both of them involve extra maths which are not relevant. It's just, again, we have this embedded language idea. If we think about it, percentages have been around since ancient Greece, fractions have been around from before that. Decimals are the new guy on the block. Although they are the optimum way forward and they are the best, it hasn't had enough time to really ingrain itself into our language as much yet. The main thing to remember, and this is really the key point from this point moving all the way forward, is that with probability, something will always happen. Like I said earlier, it's either going to rain or it's not going to rain. There's no middle bit. It's either raining or it's not. Even if it's just raining a little bit, it's still raining. If I were to go out and randomly ask people, their age, the categories I could put for that would be maybe 50 and over or under 50. Every single person will fall into one of those categories. There's no category that is not covered by those 2 groups. So something is always going to happen here. That's the thing to think of. So if something's always going to happen, that means all the individual possibilities must add to 1 if we're dealing with decimals or fractions, or 100%. Now, what I'd recommend is when you see a table like this, it's a lot easier for us to do a quick mental conversion and switch these values into percentages when we think of the question. It does make it a lot easier. So the question that I've got for you then is, we've got a spinner and it's better than Geeta's. I'm not a competitive person. It's a fact. It is. It's got 5 numbers on it, which is 1 more than hers. It's got all the bells and whistles. It makes noises, got lights on it. It's incredible. So with our spinner, we want to know what are the chances that it's going to land on a free. If I take this spinner and I spin it away like that, what is the probability that I'm going to get a free there? So I'll give you a minute to kind of have a bit of a think, put your answers across, and then we'll kind of go through and just talk through a couple of kind of key concepts in regards to this. It is quite a nice, straightforward question. It's getting used to this type of question, which is important. So have a bit of a think. What do we think that hidden number is going to be? What is the probability that when I spin this, I will get a free there? And again, please use a calculator and make it a bit easier for yourselves as well. Oh, you guys, one step ahead, aren't you? Yes, Emmanuel, Gemma, Michelle, yeah, all good. Tegan, I'm liking that. I think it literally just either a slight mistype or just a slight miscalculation there, but the concept is absolutely spot on. That's great. Susanna as well, absolutely brilliant. Okay, so this is absolutely great, guys. So the main concept that we have to think of here is that, well, first of all, what I'm going to do is I'm going to say, is this fair? A lot of people look at this and they would say, well, there's 5 categories, so therefore it's 20% on each. And that would be fine if all of the sizes of our spinner were the same size, like Geeta's one was. However, we can tell immediately, if I were to draw a picture of this spinner, the sizes would all be different. I know straight away, if there's a 0.14 or a 14% chance of a 1 occurring, yet there's a 32% chance of 2 occurring. That tells me that if I were to draw this spinner, it's a lot more likely it's going to land on a 2. There's a 32% chance that it will land on that compared to a 14% chance. So it's all about the certainty. What I know is that when I spin this, the outcomes are it will land on a 1, a 2, a 3, a 4, or a 5. It has to land on one of those numbers. There's no other way it can go. So if I add these possibilities together, 1, 2, 4, and 5, when I add them all together, I get 0.92 or 92%. So what that tells me is that with all these numbers, there's a 92% chance that 1, 2, 4, or 5 will come up. Therefore, the possibility that a 3 will occur has got to be the difference. In this case, 0.08 or 8%. The idea, all of these have to add up to 100. When I spin that spinner, one of them will appear. So it has to total to 100% or 1 if we're dealing with decimals. But some great answers across there. Didn't really see any incorrect ones, which is fantastic. And that's going to really help us kind of move into our final section a little bit later. Now, what I want to look at is these types of questions here, because these are the main questions for level 1 and level 2 that are popping up at the minute. It's reading information from a table and then stating the likelihood. Now, if we're given this in a table, like we just had there, and it's written in decimals, then writing it in decimals or answering it in decimals is the way forward. You'll notice with both of these questions, they don't ask you to state the format. So they don't say give your answer as a fraction or give your answer as a decimal or a percentage, which means technically you could give your probability as any of them, a fraction, decimal, or percentage, and you would get the mark. I will categorically tell you now, it is easier to write this as a fraction because that's all a fraction is. We've split it into this many pieces. How many of them are we taking? It's the exact same. We have this many outcomes. How many fit our criteria? If there's 120 people at a disco and I know 50 of them are male, what are the chances that if I'm picking at random, I'm going to pick a male? Well, it's 50 out of 120. It's that middle line, out of it. If we ever see anything as out of something, it is a fraction and therefore a division. So we could write it as a fraction, like I said earlier. Writing it as a fraction is easier. If we go further and we switch it to a decimal or to a percentage, we're doing extra maths for no real reason. Okay, have a read of question 1. Pop your answers over to me when you can. We are going to go through quite a few of these. So if you do get the answer a little bit incorrect at the beginning, please don't panic. Don't worry. We have got a lot of time to correct this for moving forward. So we've got our plants here. Who have we got? It's Mia, I believe. So Mia has this information about 100 flowering plants in her shop. Okay, so we've got stem length there. We've got the size of flower there. And what we want to know is, she's going to pick one of them at random. What is the probability that the plant will have a large flower and a long stem? Ah, great stuff. Yes, Susanna and Tegan, you're absolutely spot on straight away. One thing that actually helps about this question as well, yeah, Emmanuel, spot on. And you can see with this one why it would be easy to give your answer as a percentage. But if it wasn't out of 100, potentially, it'd be a lot more difficult. So the great thing with this question, or with some of these questions, is that the marks can really, really help us. We're getting 2 marks for this top one because we're having to essentially, that will be 1 mark for the correct top number, 1 number for the correct bottom number. For question 2, it's only a 1 mark question there. I would argue that should probably be a 2, but sometimes they do get a little bit stingy. So yeah, Gemma, that's absolutely spot on. Tegan, I think that's fine for number 2 there. And Samantha, what you want to do with your answer there, make sure you write how many outcomes it's out of as well. You may get 1 of the marks there. It's quite a common thing for people to just say, there's 30 of them, or there's 45. You are right, but you need to say how many outcomes there are. So you want to write this as a fraction, definitely. Okay, let's have a bit of a look then. I can see, majority of the correct answer there again, which is fantastic. So the overall answer here should be 29 out of 100. Why so? Well, there's 100 flowering plants in total. That's all of these together. There is 100 of them. So I know if I'm picking at random, I'm making a choice out of 100 things. Okay, what is the probability that the plant will have a large flower? Okay, well, I can stop there and already cut these out. Neither of these are large flowers. Okay, if it was just we'll have a large flower, then it'd be the total of these. In this case, it's what is the probability it will have a large flower and a long stem. These 29 here are the only ones that fit that category. There are 4 groups here. We've got small with a short stem, small with a long stem, large with a short stem, large with a long stem. There are only 29 of them that fit that outcome. So our probability will be 29 over 100. With this one, you could easily write that as 29% or 0.29. But again, you're doing extra maths there that you don't really need to do. Now, the really important thing to bear in mind with these is the wording. It's very common for them to say, give your answer as a fraction in its simplest form. That is a huge advantage for us. It means, well, okay, I'm going to give you my answer as a fraction, fair enough. But also by them saying in its simplest form, they are giving you an extra mark for completing simplification. Most of the time, these tend to be on the calculator paper, which is where the scientific calculator comes in very, very useful. You type in your fraction, it simplifies it for you. It's a very easy extra mark to get. They also give us a very big hint, because when they say give your answer as a fraction in its simplest form, it tells us that the fraction that we have can be simplified. So therefore, it eliminates other choices. If there's like an odd number, that's potentially not going to really be one that we're going to be considering straight away. So this is for the first question, quite nice and straightforward. I've seen quite a lot of people have obviously put in the answer for the second question as well. The second question, what we need to do is just bear in mind what totals we've got. That's the important thing here. So for part B, we've got Mia will take at random a plant from the 72 plants that she has. Oh, sorry, from the 72 large flowers. So we've excluded these. We're not even bothering to look at them. We've taken them away. There are only 72 flowers now. So our chance it will be out of 72. So in this question here, obviously, it tends to be you get 1 mark for the top answer being correct, 1 mark for the bottom answer being correct. It's not always the case. Obviously, here they are getting just a little bit stingy. So what is the probability that the plant will have a short stem? Okay, well, out of these, there are 43 of them out of this 72 that fit that criteria. And that's the main idea. It's just making sure, take your time to read the grid carefully. Again, for these, you've got 1.8 minutes to answer that one. That's quite a nice amount of time. Okay, well, it's out of 72. How many have a short stem? And again, cross off the bits that you don't need if that's going to help you. So the answer for the final one then will be 43 over 72. So we're going to go a step further. I'm going to show you the most common type of question where it's linked in with a previous type of question as well. So do me a favor, don't start filling in this table. I will reveal that to you in a minute. I just want you to see what this tends to look like. So like I mentioned before in our reading and drawing data unit, it tends to be that you get given part A, which is complete the table, 3 marks, absolute winner. So we get that in there, 3 marks. That's a very nice, easy 3 marks to get. We can cross-reference and check all of the answers. It's a lovely, lovely thing to get. You then get your follow-up question, which tends to be 1 or 2 marks, and it's asking you to give a probability about something. So the question we've got here is, Tim did a survey at a large shopping centre. He asked 400 visitors to the centre to choose why they visited. Complete the two-way table. So we can go through here, we can do our Sudoku, and we can get all of these gaps filled in nicely. That's going to get you 3 marks. Now, the great thing is the marks from the bottom are always going to be independent of the gaps that are filled in. And what I mean by that is, even if you couldn't answer that table, if for some reason your mind went completely blank and you went, I don't know how to fill in a two-way table, you could still answer the bottom question. So hopefully that helps you think with a bit of process of elimination what your answer can and might be. It's not going to include any of the numbers that you've had to fill in because our exam board is lovely and they want to obviously carry those marks over for you. So we have these here, all good. Then we get our probability question. So I want you guys to have a go at this one, and then this is where we're going to pause and we're going to just kind of roll out a couple of different questions, and we're going to really make sure that everyone's got a good grasp of this. Okay, from the people that are taking part in the survey, 1 person is chosen at random. So again, it's sent us already. It's from all the people taking part in the survey. What is the probability that a female who chose location will get the prize? So 1 person out of all of these is getting asked or is getting picked at random. All the names are in a hat. What is the probability that they are female and they chose location? Tegan, you are absolutely bossing this one. Okay, this is, and again, this is good though. It's where it tends to get people a little bit. So Suzanne, so for your answer there, your answer would be correct if I said, what is, okay, a female is chosen at random. What is the probability that she chose location? Your answer would be correct. Your top number is correct. Your bottom number is not quite correct there because it's only talking about the females. We're talking about everyone. Emmanuel, it's the, for you, yeah, sorry, absolutely perfect there, buddy. That is spot on. Susanna, okay, yeah, I can see, yeah, nice correction there as well. And Suzanne, yeah, great stuff as well. It's a very common thing for people to do where, reading the wrong total or maybe one of the wrong values. Do remember, 2-mark question. If you get the top mark or the top one correct and the bottom one, you're getting 2 marks. If not, you're going to get one of these anyway. Michelle, yes, absolutely spot on. The great thing is, again, it could have said give your answer as a fraction. That would be ideal because if they did say that, and that's all they said, then we would know that it was unable to be simplified after that as well, which is always an added bonus for us. And Gemma, yeah, okay, guys, this is absolutely fantastic. It really is. So the answer we're looking for here should be 23 out of 400. From the people taking part in the survey, that is everyone, all 400 of them. What is the probability that it was a female. So I can, again, process of elimination. It's not these guys. We're not talking about the males at all. It was a female who chose location. It was only these 23 people that fit both those categories. Are you male or female? Why did you come to the food court? Okay, I want to kind of stick with this for just a minute. I'm just going to modify the question and just ask you guys again, and we're going to just kind of go over and practice this a little bit. So I'm going to leave this part of the information the same. Okay, so from the people taking part in the survey. However, what I now want to know is what is the chance? So again, they could say, what is the chance, the probability, the likelihood? So what is the chance that a male who chose food court is selected? And then to aid even further, give your answer as a fraction in its simplest form. So hopefully that helps a little bit further. Okay, it's that extra bit of information. Give your answer as a fraction in its simplest form. That's telling you that this fraction can be simplified. Or it's a frac onion, I think I've got there. That's better. Okay, so have a bit of a think. Let me know what you think. So again, this would change the value of the question as well. This would now be a 3-mark question. You can see how easy it is for people to embed this extra kind of skill on there. Okay, let's have a bit of a look then. So Emmanuel, yeah, spot on. And again, that's great stuff. Put in your normal answer and then simplifying it. Brilliant. Michelle, you would get 2 of the marks. Okay, you've got the right thing. You have simplified it, but it's not fully simplified. Do remember, this is a calculator question. Utilize this calculator. You know, if you've got a scientific calculator, type in that sum, and then it will simplify the fraction for you. It is one of the only downsides. If it says give your answer in its simplest form, if it's a simpler form, we don't get the mark, I'm afraid. Tegan, yours is a little bit off there, that first response. I don't know if you sent another one in.
Thanks, Tom. I'm actually struggling to remember how to do the fraction on my calculator.
It's not just you. There was quite a few of the people
I've been pressing S and D, shift. I can't seem to. It keeps coming up with error when I'm trying to, and I can't get a fraction up.
One thing that can work for you, you can actually, if you see, hopefully this button here.
Yeah, that's what I was pressing.
If you press that and literally just type in the number on top and the number on bottom.
Okay, so if I start with 40. Do I need to press up and down or anything? The blue circle.
So what you can do, if you type in 40 and then you can press down there and it will move you to the bottom of the fraction. Then type in the bottom number and then just press equals and it should do it for you.
Oh no, it comes up error. Something AC in brackets cancel. Go to 2 arrows. I might need to look at this.
Okay, if not, one thing that might work is just type it in. We know that that's just a sum in itself. You know, when we write as a fraction, 40 over 400.
Yep.
If you type that in as a sum, 40 divided by 400, it will do the same thing.
Okay. I thought it'd be. I should start trying to use the fraction button, but
that's okay. We can have a little bit of a look at the end of the session as well, and we can hopefully get that one simplified there.
Okay. Sorry. Do I need to do anything after that? I've done the 40 divided by 400, which obviously gave me the 0.1.
Okay, so that's 0.1. So I mean, technically, well, with this question, I've said to give your answer as a fraction in its simplest form. So if you've got 0.1, your calculator was one of the newer ones where it had the shift button in the top left, wasn't it? The blue one.
It was, but I'm using my son's one because I thought it'd be easier, but I might revert back.
No, you're fine. You're fine. If you're using that if you've got the other one, just press SD now, and it will switch it from 0.1, and it should come up as 1 over 10.
Oh, okay. Yes. Okay.
So the SD button, you don't have to press shift or anything like that. If you've got the SD button, you just press that button on its own, and it will do it for you.
Oh, thank you.
No worries. No worries. Okay, so a lot of answers there. Majority of them have come in kind of correct. The answer we're looking for, so it's still out of everyone. We're looking for a male. Okay, so that already narrows our choice down. So if it was just a male, there's 173 of them, but it was a male who chose food court. There are only 40 of them out of 400. Please be careful. A lot of people have put 40%. Obviously, a percent is out of 100. So this wouldn't be 40%. It would actually be 10%. So the best way forward, like we were just talking about there, if you've got a scientific calculator, then use it. Type that fraction in and press equals, or just type the sum, 40 divided by 40, and then either press the SD button, or if you've got a slightly newer one that doesn't have that button, you can press shift and equals, and it will do the same thing. When it simplifies fully, you should end up with 1/10. If you've half simplified it, then it will, again, you're not going to get the full simplification mark. Suzanne, yeah, absolutely fine. It's my intention is, guys, that we're just going to go through. I'll make up a fair few more of these just to really get the hang of it. That's the idea here, because it is the most common type of question. Okay, so we've looked at this idea then. What I now want to know is, what is the likelihood, probably spelt wrong, do apologize, that it was someone who chose. Okay, so a little bit different then. So we're still talking about everyone here. So it is from the people taking part in the survey. One person will get picked. What is the likelihood that it was someone who chose location? Give your answer as a fraction in its simplest form. And I need to actually simplify that down myself as well. Wrong button. Okie dokie. Emmanuel, yeah, spot on. Absolutely great stuff there. Suzanne, yeah, brilliant. Samantha, great stuff. Yeah, Gemma, that's great. People in the future that are actually watching this recording, I'm sure you've got it right as well, so you can have a well done as well there. Michelle, yes, this is looking great, guys. It's just one of those things, it just takes a couple of practice runs and then you really start getting the hang of it. So with this one, we're only really reading into one category. So I will pop the answer up now because I can see a lot of people obviously put it across. We are looking at 11 out of 100. When we're fully simplified, you could also say 11% because it's out of 100. Just remembering that link can be very, very useful. What is the chance that they chose location? Well, it doesn't matter if they're male or female. The prize went to someone who chose location, and there was 44 of them. Obviously, you wouldn't be asked to use this information because you had to fill in the table, but we're just practicing the skill here. Okay. Yeah, Tegan, no problem at all. If you, what you might want to do, just write down the answers on the side. That's absolutely fine. You don't have to submit them at all. Please don't cause yourself any extra stress or worry or anything there. That's absolutely fine. Yeah, and for a lot of people, it's the same. You know, some people prefer to just write the answers down on paper. That's all good. Just let me know every now and then. You know, if you want me to pause or slow down or anything like that, or if you're absolutely fine, which I'm sure you are, just let me know that you're happy to move on, etc. But thank you for letting me know as well. Okay, we're going to modify this a little bit. We're going to kind of go up and we're going to change it just a little bit. You'll notice now I'm covering up this piece of information as well. So what I now want to know is out of all the people who visited for the food court, what is the chance that a male is chosen at random? Okay, there you go. So again, it does actually sound But there's a lot more going on here. You know, out of all the people who visited the food court, what is the chance that a male is chosen? Oh, sorry, a male who is chosen at random is selected. So I've worded that a bit badly there. Give your answer as a fraction in its simplest form. So again, it is helping us again with that simplest form kind of idea as well. Do use a calculator. It's going to make life a lot easier. You can do it without a calculator, but again, it just makes things a bit easier there. Oh, you guys are very quick here. Yeah, Suzanne, perfect. Samantha, Gemma, Michelle, yes. We've nailed this. Bear this in mind as well. This is the most common type of probability question. We really want this to pop up. There's 3 marks for that table, which everyone is fine in doing. If you're being asked to simplify the fraction, that's another 3 marks. That is 6 marks from your paper on this one question. Okay, that's amazing, Emmanuel. And Tegan, I'm going to say nice one as well. I know obviously you can't submit the answer at the minute, but I'm going to go ahead and just assume that you've nailed it as well. So Susanna, yeah, so for yours is absolutely fine. So you've identified the right information. It's just it's been simplified a little bit incorrectly there. I'm not too sure how you got to that value. I mean, if you're not using a calculator, it'd be kind of halving it first of all, which should take you down to 45, 600. So 20 over 48, which you can then half again to 10 over 24. Oh, yeah, so it's just, I think that you just missed off the 0. So it should be, you should go down to 10 over 24, and then you can continue to simplify from there. The 10 over 24 will then be 5 over 12 at the end point. Yeah, it's just, yeah, so Susanna, it's just the so you put in the division of 4, it should be the sum itself should be 40 divided by 96. Okay, so this is looking good. People seem like we've got the general kind of idea, the general gist of this, which is absolutely fantastic. Now we're going to move on. Our next topic is going to be about the idea of, is it fair? And these are really the last 2 topics. We're going to talk about this, and we're going to have a bit of an extended talk about our kind of final point as well. So what we're going to do, we're going to pause now. We're going to have a quick break. So I'm just going to very quickly pause the recording if I can. And yeah, okay, we'll pause that there. Okay, so welcome back from the break. Our next topic then is, again, it's a super duper short one. We're just talking about, is it fair? It is something that we need to be aware of. So what I'm going to do, I'm just going to give you some data. I'm going to give you a question and see how you respond, and then I'll fill you in on kind of the context of the question. So we might be asked in functional skills to state if we think something is fair or not. So we might be asked to say if it's fair. There's some other words that are used, you know, obviously unfair, bias, loaded, rigged, kind of things like this. You won't tend to hear the more colloquial ones there, but in regards to is it fair, we might see the word bias being used. So that just means unfair, essentially. So if we look at the table below them, what this table shows us is the dice, or a normal, what's maybe a normal, a 6-sided dice that's been rolled 100 times. So this is obviously a tallying frequency diagram here that shows us the total outcomes. What I want you guys to kind of submit an answer for is, do you think this dice is fair, or do you think it is unfair? Can you also put a comment as to why you think, what answer you think? So this would potentially be a 2-mark question. And again, it's this thing where they can, or people can ask you to, you know, make a comment or, you know, state something as well. We tend to see it in statistics quite a lot with our kind of, you know, make a comment about the range or the mode, or a comment between 2 data sets. Here, again, you could be given some data and just say, is this fair or not? What do you think? So let's have a bit of a look. And again, it is a very common. Yeah, so Emmanuel, yeah, that's the most common answer there, definitely. Tegan as well, yeah, supporting that. Susanna, yeah. So again, it's the most common answer here, and again, I'll move on at this point because it doesn't take too much kind of thought for it, probably just longer to type the answer over to me. The most common thing that is said is that this dice is not fair because 6 has too high a frequency. That's the most mathematically you could word it. But you could say no, it's not fair because 6 appears a lot more than any other number. If we think about it, if this dice was fair, then every outcome would be just as likely. So we'd have our 100 attempts, and we would divide that by 6. We would expect our answer to be, so when I do that, I get 16.6 recurring. So we would expect an answer around 16 or 17. Now, again, this is not set in stone. Imagine if I was flipping a coin. It is just as likely it will land on heads as it will on tails, but it doesn't mean it will go heads, then tails, then heads, then tails, then heads, then tails. That's not how it works. I could flip it 100 times and get heads every single time. The chance of that particular thing happening is very unlikely, though. So, in regards to this, most people will say that the coin is, that the dice is biased or loaded, rigged, whatever you want to say, because the frequency of 6 is considerably higher. So if we look at this, 15, 12, 13, 13, and 12, not too far away from 16. And what you'll tend to find is with more data, your values will get closer to that general kind of idea. 35, on the other hand, that's over double the likeliness. It does seem like a lot. So if you've put this answer, then you would get both marks. I believe it's biased because the frequency of 6 is a lot higher than the others. That makes sense. You'll get 2 marks. However, you can also get the marks for saying the opposite. It's one of those questions where if you make the comment and you explain yourself, then you're pretty much guaranteed the mark here, or at least 2 marks in a lot of the cases. You could also say, well, I can't really tell you. It might be biased, but it might be completely fair. The reason it might be fair is because if I've rolled this dice 100 times, it might just be that 35 of them were 6s. It's not impossible. It's more unlikely, but it's not something that couldn't happen. You know, if you got a load of people and everyone rolled a dice 100 times, this outcome might occur. So you could say, I would need more data. You know, even if you just said that first point, that's absolutely fine. Just it could be fair, because that might just be the outcome. It's unlikely, but it could be the outcome. That's fine. That will get you 2 marks as well. However, it is the idea here of saying, if I rolled it, let's say we rolled the dice another 900 times, so in total we've rolled it 1,000 times, we would be expecting, you know, about 160 to 170 outcomes on each number. Now, if it turns out that then there was 350 on the number 6, that is a lot more data to suggest that it is weighted or loaded. So the more data we have, the stronger our correlation, or the stronger the links are that we can draw from something. Again, you're not really going to get asked to go into any detail on this. It is just a case of potentially being asked, do you think it's fair and why? I just wanted you to be aware that obviously you're going to essentially get the mark for stating it either way. Okay, so what we're going to go on to and talk about now is something called a probability tree. It is something that is only going to appear for level 2 learners. And with that being said, you're never going to be asked to draw a probability tree. As I always say, I do recommend, you know, if it's tricky, draw a picky. Draw a sketch of potential outcomes. That can be very, very useful. But you don't have to actually, you'll never have to construct one of these. The questions are always very, very structured in regards to Edexcel. A probability tree is just a map or a way of mapping potential outcomes. And it works in the same basis and the key idea of what we've already looked at. That is essentially the 2 main ideas being that all probabilities will add up to 100% if we're talking about percentage, or 1 if we're dealing with a fraction. Something will happen. Something is definitely going to happen. The other thing that we're going to look at here is that we are going to multiply probabilities to find out how many outcomes there are, or what level of outcome there is. This will make more sense in a moment when we go through the actual example. Okay, I think what I'll do at this point is very quickly do a sketch for you of what this would look like in regards to our coins, for instance. So what this will look like, if I flip one coin, I could get, let's say, heads or tails. Now let's say I flip a second coin, I could also have heads or tails. So we can see now there are 4 outcomes that can occur. Now, because it's a coin, and we're going to assume that it's a fair-sided coin, I'm assuming most people will be very happy at this point to say, well, all of the outcomes are just as likely then. When I flip the coin, it's just as likely to land on heads as it is tails. So if we look at this end, we would be quite happy to say that there is a half chance, or we could say let's say a 50% chance. So I'm going to use the top branch here to explain in percentage and the bottom to explain in fraction. I think that's going to help us here. So there's a 50% chance of a heads. There is a half of a tails. It's the same thing. I'm just writing it in a slightly different way. Now, when we flip the coin again, so let's say we just got the same coin and we're going to flip it twice. I flip it once, there's a 50% chance I'm going to get a heads. Flip it again, then I've now got 4 outcomes. I either get heads and heads, heads and tails, tails and heads, or tails and tails. Now, when I do this flip again, the outcomes are the same. It's still a 50% chance that I'm going to get a heads or a tails, and it'll be 50% for all of them. So again, down here, I'm going to put this as a half, just as a fraction. So, okay, if I pose this to you then very quickly, and we'll try and build from here. So my 4 outcomes then, I've got heads, 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 tails, tails, heads, and tails, tails. What I want to know is, what is the probability that I will get 2 heads in a row here? Give your answer as a fraction, percentage, decimal, whatever you're thinking. If I flip a coin once, okay, 50-50 chance, I flip it again, there's still a 50-50 chance. There's 4 outcomes. Essentially, they're all equally as likely. There's no trick question here. I'm not trying to catch you out. What is the probability, or what is the likelihood that I'm going to get 2 heads in a row? Okay, yeah, fantastic. This is very good. So Susanna, yeah, that's spot on. And Emmanuel, yeah, you're completely correct. So Tegan, your answer should be half as much there. Yeah, there you go. That's the one. Yeah, and don't worry, it can get a little bit of confusing, and this is where people tend to start thinking, oh, it's like if you ask people how many outcomes there are for certain things, that's where it gets a bit confusing. I haven't done that because it's very rare that that type of question actually pops up in regards to it. We've looked at it from a table, and that's really where it tends to happen there. So Michelle, yeah, absolutely spot on as well there. Okay, I'm going to move on. So what we're saying is that there is a 25% chance of this happening, the heads and heads. There is also, down here, there's a 25% chance of tails and tails happening. Okay, so all of these are just as likely to happen. So this is, sorry, just linked here with this one. Now, this is fine if we are dealing with things that are equally as likely. It's simple, really, isn't it? Well, there's a half of a half chance. We know that a half of a half is a quarter. It gets a little bit more difficult when we think about the maths, and they tend to use decimals in this system. So that's why I want to try and explain mathematically why these answers are the way they are. Here, hopefully, people are quite happy with this. Well, there was a half chance at the beginning, and then I've got a half of a half. Half of a half is a quarter. How I would word that is I've got half lots of a half, okay? So that is a half multiplied by a half, and that's going to give me my answer of a quarter. We don't ever multiply fractions. Don't worry, that will never come up on the paper. It's just to visually show what this would look like as a fraction. People are also very happy with this as a percentage. Well, okay, we can make it look even nicer. We know that this here, let's say there was 100 coin flips. Okay, that can make it even nicer and easier to view. 100 coin flips. We would expect 50 of them to land here. Out of that 50, it is going to split evenly each way, which is why you get 25. We've got 50% of 50%. We are taking 50 and we are halving it again. Now, this sum in itself, 50% of 50%, we can see that vision. It's going to be 25%. It is a lot easier to write this as 0.5 lots of 0.5. When we solve these questions, or when we are looking for the overall probability of a certain outcome here, let's say heads and heads, we just multiply down the branch. 0.5 times 0.5 is 0.25. The reason we don't use, I mean, the percentage idea makes it very easy for people to see. Well, I've got 50%. If I found 50% of that, I take this, and the quick way to do it is just half it. And that's what I've got. This is the exact same as saying a half, timesing by a half, or 0.5. I've got 50% chance of scoring this 50%. So if this is, again, yeah, if you are a level 1 learner, please don't worry. This is only for level 2. The main thing that I want to kind of highlight with this is I'm just trying to show you why, as a bit of an explanation, we multiply down the branch. 0.5 times 0.5 is the same as 1/2 times a half. It is the same as finding 50% of 50%. This is probably easier to visualize and imagine, but the maths is longer. What I would be saying is, well, 0.5 times 100 is 50%. Then to find 50% of that, I've got to take this number, divide it by 100, multiply it by 50, and that will give me the percent, which if I want it as a decimal, I then have to divide by 100 again. You can see there's a lot of this scaling things up 100 times just to scale them back down again. What you are doing is multiplying. That's the point I'm trying to get across here. You have 0.5 lots of 0.5. Okay, it's a little bit confusing. Bear with me though. I want to show you this in context. So the type of question that can pop up is going to be like the following. It is always, or it tends to be, a 3-mark question. 2 of the marks are for filling in the table. 1 of the marks is for a question at the end. So this is where we're going to kind of round off the session. So we've done a survey, and we've gone out and we've spoken to people. We've got 2 different age groups, and we asked them what was their preferred method of transport. So first of all, we asked people their age. Okay, we said, are you over 30 or under 30? Now remember, you're going to fall into one of those categories. What we found was that, and again, this is how they tend to write it. They'll write it as a decimal. Feel free to convert it to a percentage in your head. 0.3 people that we asked, because it was completely random in a general population. 0.3 people were over 30. What percentage of the people, or what decimal of the people, were under 30? So this is where it's interesting. You don't need a set number. If there was 200 people there, you could tell me how many were over 30. This is just explaining the percentage or the difference between them. Ah, yes, guys, brilliant. So Emmanuel, Michelle, you're both absolutely spot on there. And again, looking at it as, imagine it as a percentage, it's a lot easier. If 30% of the people are over 30, what percent are under 30? Tegan, great stuff. Yep, Suzanne, brilliant again. Okay, so the great thing is, Susanna as well, great. The great thing is, at this point, if you've put 70% or 0.7, you have got 1 mark, okay? It's all about what adds up to 1. In this case, you're either over 30 or you're under 30. If 30% are over 30, 70% are under. Now, out of these groups of people, we then asked them another question. We said, what's your preferred method of transport? Do you like to travel by the car or by bike? And that was it. A lot of people were trying to be wisecrackers. They were like, oh, I like to travel by pogo stick. We were like, no, what one do you prefer? Not saying if you do travel in that way, but there are only two options. What we found for the people in this section here, the over 30s who travel by car, is that 70% of them traveled by car. So what percentage of people here, of the over 30s, traveled by bike? It's like you guys can read my mind, isn't it? It's amazing. Okay, brilliant stuff. So a lot of correct answers there. Yes, great. So if 70% of the people travel by car, the rest travel by bike. Okay, so this would be 0.3 or 30%. Okay, let's look at our under 30s then. We spoke to these guys and it turned out that 40% of them traveled by car. What percentage liked to travel by bike or preferred to travel by bike? I'm liking the speed of the answers here as well. It's absolutely fantastic. So again, with this, you could give your answer as a percentage, as a fraction, as a decimal. I'd say to give it probably as a decimal because it kind of keeps the theme there. But it's that nice quick conversion in your head of knowing 0.4 is 40%. Doesn't matter what context you put it in, that is what it is. So in this case here, we know that 40% of the people like to travel by car. So therefore, the remaining 60% like to travel by bike. So that there is essentially 2 marks for you. It tends to be, or every question that I've seen involved in this, they will leave out maybe 2 bits of information. Maybe I'll cover up this piece of information and maybe this piece of information. They cover up 2 of them and they say, fill in the blanks. It can be that it goes to a little bit more difficult numbers. I've seen it go to 2 decimal places. Maybe this value here is 0.35. So what is the chance here? Okay, well, it's up a little bit. It's going to be 0.65, I believe. But that, out of this 3-mark question, you have got 2 marks there. So please, I know I've just been on that kind of rant about finding a percentage of a percentage and all the rest of it. Just bear with me. It will make sense, hopefully. So at this point, you have got yourself 2 marks. Now, the final question that people ask is for a certain outcome or a certain probability or a combined outcome. As we looked at with the coin, it was very easy. Well, it's a half chance of that and a half of a half. So a half times a half is a quarter. We know this. If I had a whole thing, I cut it in half, then I cut it in half again. Each outcome was 25%. Now, this is different because it's not shared equally. Now, if you want, and I as much as it pains me to say this, I feel like my explanation is quite good, but it can do with improving. If you can just remember the pure maths of this, then please take it. If you understand the concept, even better, but it's a very nice and straightforward thing. If you want to know what the combined outcome is, you multiply probabilities together. So given that, can anyone kind of suggest an answer? What is the probability that someone chosen at random is over 30 and travels by car? Yeah, Emmanuel, spot on. So again, use your calculator. There you go, absolutely brilliant. If the answer doesn't make too much sense in a minute, bear with me. Again, I will try and go through and give an extra kind of bit of explanation for it as well to help out a bit further.
Can I ask something? It's
Yeah,
like
yeah, of course.
before another one, you said it like 100 and you cut it to the half and you're gonna go like 1/4. You explained that, right?
Yeah.
Or yeah. And now when you take 100 from 0.3,
Okay,
Take
you're,
50.
it's like you can read my mind. Okay, let's say we had 100 people then. How many of them will be over 30?
Over 30. Oh my God.
So I know you're okay. Sorry, I've got to put you on the spot a little bit there, but yeah,
Yeah,
before,
0.3.
yeah, 0.3. So that's 30%. Yeah, that's the same thing.
Yeah.
So we know if we're dealing with 100% out of 100, it makes it easier. So we know that 30 of them are in this category. So then what we've got is 70% of these people like
Okay.
to travel by car. Does that make a bit of sense there?
Yeah. Yeah.
So it's like, and thank you very, very much for speaking up and kind of, mention that. That was the point I was going to go on to, but it kind of clarifies for me that it's a good point to go on to as well.
Yeah.
So to get the correct answer, what you aim to do is, like I mentioned, you simply multiply down the branch. What you're doing there when you multiply 0.3 by 0.7 is you are finding 70% of 30%, or 70% of 30. It's the exact same as essentially you're finding a seventh of a third as well. Or no, sorry. It's a horrible fraction. Let's not think about the fractions. It gets a lot harder. It'd be 7/10 of 3/10 essentially. So the idea though is when you're multiplying down the branch, you are doing the exact same as finding those percentages. It's just with percentages, you are increasing values by 100, then decreasing them. This is just the pure raw form of what you're doing. So if you get this question pop up and you're a level 2 learner, just remember, whatever branches you're going down, just multiply the two numbers together and you'll have the correct answer. There are some ways you can check this as well though. And like, we just had there, the idea with this, Tegan, yeah, it's a really good idea there. You could do that, but what you'd be doing, if you viewed it as a percentage, you'd be looking at it as out of 100. So you'd be looking at 0.3 times 0.7. If you do that sum on a calculator, it will give you 0.21. So if we remember, when we multiply decimals, we make them bigger first of all, so 3 times 7, but we have to divide the answer by 100 because it is going to be obviously 10 times bigger from the 0.3, 10 times bigger from the 0.7. But the idea here is, we had 100 people, 30% of them, so that is just 30 people are over 30. Out of them, 70% like to drive a car. This answer makes sense. 0.21, that's 21%. If this was even, if this was 0.5 and this was 0.5, then it'd be a 50-50 split like this, and it would be 15 people travel by car, 15 people travel by bike. The fact that 21% travel by car makes sense because out of these 30, more of them travel by car, higher than 15. Okay, making sense. So let's look at the next outcome. And you're only going to be asked one of these, so please do bear that in mind. So what is the probability that someone is going to be over 30 and like to travel by bike? Now, when I posed the first question to you, there was only one way to answer this question. There are now two. So again, imagine it's a percent, imagine it's out of 100 if you want to. The shortcut that I just told you about multiplying down the branch, that will work, okay? Hopefully, though, the more of these we go through, the more it will make sense why we just simply multiply them. Yeah, Michelle, that's brilliant. And again, it's a really good conversion there to the percentage as well. Okay, Emmanuel, I'm liking the thinking. It's a little bit different with this aspect, though. What we need to think of is the total here. I'm liking that you're trying to see the alternative kind of way of looking at it. Imagine what the total percent is. Out of this, there was 30% of people. If 21% is here, what percent must be here? Susanna, yes, absolutely spot on. So the answer we're looking for here, again, quickest, easiest way to do it, 0.3 multiplied by 0.3 is 0.09. So that's quite interesting. So a couple of people will put 79%. I'm a bit not too sure where that answer's come from, but a couple of people have put it, so there is a reason for it. In regards to, so how we've got to this answer, simply put, we've found out 30%, so that would be 30, and then we found another 30% of 30, which is going to be 9%. In simpler maths, 0.3 times 0.3 is 0.09. The other way of looking at this is just to simply say, well, at this point, we had 21% of our 30%. Okay, so all of these people equated to 30% of the overall population. Out of that 30%, 21% of them travel by car. The remaining must like to travel by bike. So 0.09 add 0.21 is 0.3, which is 30%. So that's the other way that you can look into this. Okay, just to really kind of draw this bit home, I'm sure you can already predict what my next question is going to be. What is the likelihood of, if I pick someone at random, that they are under 30 and they like to travel by car?
Tom, can I just ask a quick question?
Yeah, of course. Please feel free. It's going to help me probably.
I just got kicked off, so you might have just explained it while I was trying to log back in.
Oh, okay.
So how come, so like, for example, obviously, if we know it's 0.3, we know that the other one's 0.7 because it's got to add up to 1.
Yeah.
So I thought when at the end, if one of them was 0.21, I thought it'd be 0.79 because it would reach a whole, if you see what I mean.
Yes, thank you very, very much. That's a really, really good point because it wasn't just yourself that put that answer. Okay. If you view it like this, it's going to help even further. So at the beginning, there was 2 groups. Okay, you always fall into one of those groups. So everything in this category adds to 100. In this case, out of this percentage, it doesn't matter how many people there were, but out of that many people, you either done this thing or you done this thing. So these both add to 100% as well. In the end, we have 4 outcomes. So overall, all 4 of these potential outcomes will add to 100% or add to 1. Kind of like if you imagine when we flipped the coin and we flipped it again, we had 4 outcomes. Each one was 25%, 25%, 25%, 25%. One of them is that okay?
I see. It's clicked. It has clicked. I see what you mean. Yeah, because it's not just that one category.
It's not just that one
all
branch.
4 of them.
So it's because it goes into the 4 categories, we're going to end up with that idea of one of those outcomes will happen. They must all add up to 1. And it's just spotting where things add to 1. Here, you're picking one of these 2 options. It's got to be 100%. Here, you're doing the same. Here, you're doing the same. And all in all here, when we get all 4 of them, this will also add to 100%.
Oh, thank you. That makes a lot of sense.
Well, no problem. No, thank you very much for asking it as well. Again, this is probably I'll be completely honest, it's probably my least favorite topic to try and teach because trying to find a very nice visual explanation is quite difficult. You know, trying to explain it with percentages and with fractions and decimals tends to help it click. But this idea of just multiply down the branch, people tend to get the question right in the exam, but they're a bit frustrated that they don't know why they multiply down the branch, if that makes sense.
So basically we have 30% already on the top. So the remaining 70% should be on the bottom.
Ah, Emmanuel, you are a hero. Yes, this is going to total up to 70%. Whatever it is, we know that's going to total up to it. So what I'll do for you is I'll reveal the next answer because a lot of people have already put it in. So we should have 0.28 here as our next answer. So if I just check the chat, and that is the majority of that. And yeah, I can see, Suzanne, you've gone the 1 step further. And so have you, Emmanuel, as well. So a couple of people have gone 1 step further, which is fantastic. So what you'll find now is, now that we know this, and based on what Emmanuel has just said there are now 1, 2, so there's now 3 ways to understand what the answer here is going to be. you can multiply down this branch. There's a 70% chance that you're under 30, and then out of that group of however many people it is, 60% of them travel by bike. You can just do the maths, 0.7 times 0.6. Or, like Emmanuel pointed out there, this is 28% out of 70. So what is the remaining group? Well, it has to be the rest of the group that adds up to 70%. So it has to be 42%. The other way you can view it is, well, this and this and this will add up to something. One of these 4 options must be chosen. So the final answer has to be 0.42 or 42% there. I'm getting a lot of correct answers, a lot of information coming there. That's absolutely amazing. I feel like this explanation is better than the previous video, which is why I'm deleting it. And I hope that has kind of helped a bit. The main thing that you need to bear in mind is that this is a level 2 question only. It will always be part of a 3-mark question, and you're not going to be asked to explain any of this at all. So if you can remember the maths, it is going to get you through, it's going to get you the marks, and it's going to mean that you never have to do maths again. 2 of the marks are for filling in the gaps on the table. Everyone's fine with that. Each category adds up to 100%. One of the 2 options is getting picked. At the end, everything will add up to 100%. Okay, that helps us a little bit. But the main thing is just knowing if it doesn't make complete sense, just remember you multiply down the branch. Whenever we have more than one probability, we multiply along it. It's the same idea as if you imagine if you're rolling dice, for instance. If you roll 1 dice, there are 6 possible outcomes. If I roll 2 dice, a lot of people immediately think, oh, well, there's going to be 12 outcomes. It's not. There are 36 outcomes, because each one of those 6 outcomes then has 6 lots of further outcomes. So that is the last kind of topic there that we need to look at. It is just for level 2. If the explanations helped, then I hope that that deeper understanding is there. Thank you very, very much for people for obviously putting the questions and answers across there as well. I really do appreciate that. That is actually going to include everything that we need to know about probability. So we have had our introduction and we've talked about the non-numerical side of this. We talked about just things, how likely they are, if it's impossible or if it's certain. We then looked at our main point, and this is for level 1 and level 2 learners. The main topic point here was those simple probabilities. Like I said, it always tends to be at the moment they are embedded with those 3-mark table questions. We get a 3-mark table question, and then we get probably a 2-mark probability question. If it says as a fraction in its simplest form, then we've got 3 marks. That's a 6-mark question right there, and that is absolutely brilliant. We talked about if it was fair or not, and hopefully that kind of explanation helped out a little bit in regards to, essentially, you can argue it either way. Most people tend to say the same thing. If one frequency is considerably higher than the others, then it's occurred more often, so therefore it's more likely to happen. Makes sense. We finally then, we had a look at probability trees and dual probability. Probability trees are a lovely, lovely tool to draw a quick sketch if you need to. You will never be asked to actually draw one, but again, they can help us to identify or to think about a problem logically. When we're working with them, filling in the gap seems to be the easy one. Things add up to 100%, but just remember that when we are working out the outcome of 2 kind of probabilities, we always multiply it, multiply down the tree branch. If we remember that, then you're going to get that extra mark there, and that's really what we're aiming for. Okay, so before we go on and we go on to our kind of review, there are some random kind of past paper questions. We're not going to look at all of them. I just want to put up one for you because I'm aware that this question is to do with probability. So this is an exact question from an exam, and it is a level 2 question for 1 mark. Okay, there's no tricks with it or anything like that. Have a quick look. Let me know what you think, and it is on the calculator as well. So we've got Fez has 150 balloons in a bag. 43 are red, 67 are blue, 40 are yellow. He picks one at random. What is the probability that the balloon he picks is blue? You can see it's like one of those table questions, but even nicer. Susanna, amazing. You are the first person to get your first mark on your probability question for a level 2 question. Obviously, all the other ones, you know, I've explained about the table, that is a very kind of common question there. Do just remember with this, it's a 1 mark question. That means they are estimating, or they're giving you approximately 1.8 minutes to answer it. It is probably going to be a question that you can look at and either complete one sum, or you can just stare at and you know the answer or you don't. Answering as a fraction is going to make it a lot easier as well. So Emmanuel, spot on. Gemma, okay. Okay, so Tegan, I'm liking it that you've gone with that. It's not the correct answer, but it was a question before. So there was actually a question before. It was on a level 1 paper as well, where it was saying about maybe if we take a question like this, so it said Fez has these balloons in a bag. He's got red balloons, blue balloons, and yellow balloons. What is the probability that he picks a black balloon? That was a question on level 1 paper before. And again, for a lot of people, they're like, is that a trick? Is it not? Technically, they can still ask it because it is asking you a probability, but there was a 0% chance because there were no black balloons there. If we look at this one, though, what we should see is, okay, well, the options are, again, you can imagine drawing out a tree to this. Okay, well, there's 150 at the beginning, got red, blue, and yellow. I've got 43, 67, 40. All of them are out of 150, the chances. And what we're going to find here is that 67 of these balloons are blue. So if I'm just picking one at random, I've got 150 options. 67 will get me a blue balloon. These are the answers from the actual mark scheme itself. So as you can see here, 67 over 150 as a fraction, or 0.44 to 0.45, or 44 to 45%. That is incredibly nice of them. Any way you give your answer, they will accept it. And when you do 67, if you were to give your answer as a decimal, for instance, 67 divided by 150 gives you an answer of 0.446 recurring. So 0.4466666666. What they're saying there is that they are going to accept any answer between 0.44 and 0.45. Absolutely brilliant. So that is the first of many of these kind of random questions that are at the end of this PowerPoint. What I'm going to do now is make a suggestion to anyone that is viewing this. Now would be a very good time to go away and have a look at the probability level 1 assessment and the probability level 2 assessment, and complete them. That would be great for you. I'm going to stop the recording there because that is the end of this topic. I hope you've enjoyed it.